Ah, geometry, how lovely to be with you. Happy day. I hope your life is going well. We are going to take the next step in geometry, talking about midpoints. So why don't you pause this video and take a peek at this warm-up. I'd like you to find the midpoint of this segment. Go. Okay. So when you look at this, you probably are going to take a guess as to where the midpoint is. And if I just eyeball this, it looks like the midpoint. Oh, it's kind of hard to tell. Does it look like it's right there? Does that look like a pretty good midpoint? Sure does to me. Well, what is that point exactly? And are we sure that that's the midpoint? Turns out this warm-up was a bit of a trick question, because if you want to know the exact midpoint of a segment, you can't just eyeball it. You have to calculate it. And that's what we're going to talk about today, calculating midpoints. So in order to get into that business, you're going to want to get your notebook out and get it ready. And so the last time you had your notebook out, maybe you didn't finish up writing the questions. Maybe you've got a place where you can write a summary, kind of going back in time and shoring up some of those ideas. Then get yourself a new note page started. Go ahead and pause the video and update your notebook. All right, so on your new page of notes, you have a topic. It's called the midpoint formula. That's what we're talking about today. The essential question: how can you find the midpoint of a line segment in a coordinate plane? Make sure that topic makes it into the table of contents, and let's get started. So what would be great is if you had your notebook open to the topic that is basic geometry vocabulary. Now, if you have a good table of contents, you can look at that table of contents, find that topic, basic geometry vocabulary, find the page number, and flip right to that page. That's why we're creating a table of contents, so that things are efficient. When you look at basic geometry vocabulary, you'll see that there's a couple of words on that page that are defined, and I just want to make sure your definitions are pretty close to what I'm about to say. It might not be exactly, but as long as you have the right idea, it's okay. So what is a midpoint? A midpoint is a point that cuts a segment. What am I writing? A segment into two congruent segments. That's what a midpoint does. M in this picture is a midpoint, and I can tell that it is because AM and MB are congruent. I can tell that they're congruent because they're marked that way. Remember, that's what those markings mean. We're going to be using that idea a little bit more than we have so far. Now, a midpoint is a point, but there are other things that can divide segments into congruent segments, and those would be called segment bisectors. Segment bisectors are any object. Well, actually, you know what? I'm going to say this better. A line segment or ray that cuts a segment into two congruent segments. A segment bisector does the same thing as a midpoint, but it's not a point. It's some other object. It's going to be a ray, a segment, or a line. And when we're looking at this picture, we can see that the line CD bisects segment AB. How do I know that? Well, it's because it cuts it into two congruent segments. How do I know that? Well, it's marked that way, so I can trust that it is. That segment bisector goes right through the midpoint M, and that's another way you can tell that it's a segment bisector. It's an object that passes through the midpoint. So a little bit of vocabulary to recall moving forward. Now we can You might want to pause and record these definitions on basic geometry vocabulary if they're not quite right. And then let's move on to your new note page and start talking about midpoint stuff. So again, it's really important to think about the fact that eventually you're not going to be watching this video and you're going to want to study for a test. And so having diagrams, these pictures drawn in your notebook next to the calculations or the definitions can be really helpful. So just pro tip, draw these diagrams. So the problem is identify the segment bisector of PQ and then find PQ. In other words, the distance between P and Q. And so to identify the segment bisector of PQ in number 1, we have to find that thing that cuts the segment exactly in half or into 2 congruent segments. And in this case, it looks like you could say a couple of things. Point M would be a midpoint, I can tell, because it cuts the segment into 2 congruent segments. But there's also the ray MN, where M is one endpoint and it goes out through N. So you have a couple of different choices here. You could say point M or ray MN. Don't forget your symbols. That is a segment bisector. Then if we find the length of PQ, that's going to be the distance between P and Q. What we want to notice is that from P to M is 5 units. So if we know that from M to Q is congruent to PM, don't we also know that this is 5 units? We sure do, and that's why having that information is important. So how far is it from P to Q? Well, it's going to be 5 units plus 5 units, so 10. We know that PQ is 10 units long. Okay? Looking at number 2, we only have one choice for the segment bisector. The thing that cuts it in half is point M. We can see that M cuts that segment exactly in 2, and so M is your segment bisector. Now we know the distance from M to Q is 3.5 units, and since those two sides are congruent, we also know that it's 3.5 from P to M, and we can add those two together to get the whole length of PQ, which is going to be 7 units. And that's how you think your way through those. Now things can get a little bit tricky. And sometimes you're not given a number for the distance between things, and so you'll have to solve using algebra. This is where we start to bring algebra into our geometry. So we'll get to that in just a second. But let's first of all identify that point M is the midpoint of segment VW. We're being told that M cuts that segment exactly in half. And so whatever the distance is between V and M, it has to be equal to the distance between M and W. Well, what we know is that the distance between V and M is represented by this algebraic expression, 4x minus 1. We also know that the distance between M and W is being represented by this algebraic expression, 3x plus 3. But what do we know about those two expressions? Well, since those segments are congruent, we know that those expressions are the same. Whatever number they represent, it's got to be the same number. And so we can say that 4x minus 1 equals 3x plus 3. We're being asked to find the length of VM, and so we really need to solve for x in order to figure out what these numbers are. And that's what you'll end up doing with these kinds of problems. First of all, we have to solve for x. So how do you do that? Well, at this point, we have done algebraic expressions, or rather algebraic problems before, where we had variables on both sides, and we had to use the techniques of algebra, creating clever cancellations and doing the same thing to both sides in order to solve for a variable. So let's do that. There are about 4 ways you could start this problem. You could subtract 4x from both sides. You could add 1 to both sides. You could subtract 3x from both sides. Or you could subtract 3 from both sides. I'm going to subtract 3x from both sides. The reason why I choose that particular step, even though there are 4 different ways of doing it, is because with a little experience, I know that what that does is cancel my variables from the right side, and I like my variables to be on the left. And so that's why I chose that way. 4x minus 3x's is just 1x minus 1 equals 3, because we canceled the 3x's on that other side. Now I bet you can solve that. You got to get rid of that negative 1, right? And so create a clever cancellation and do the same thing to both sides. These cancel, and so x equals 4. Now you'd be tempted to think that that's the end of the problem, but we weren't asked what x is. We were asked the length of VM. Well, now that we know that x is 4, we can jam that 4 right in here. And we can figure out the distance between v and m. And we can say that it is 4 times 4 minus 1. Well, 4 times 4 is 16, minus 1 is 15. And so we know the distance between v and m is 15 units. Now, since those are congruent, we can go ahead and assume that m to w is also 15, but we can also make sure that it is by putting that 4 in here as well. Is 3 times 4 plus 3 15? It sure is. And so we know we've got the right x. It's a good idea to check. So finally, we can find the length of VM. It's going to be 15 plus 15, or 30 units. So to solve a problem like this, first of all, you're going to read the problem carefully, understand that you're being asked to find the length of VM, but you don't have numbers yet. And so be clever. Notice that 4x minus 1 is the distance between v and m. 3x plus 3 is the distance between m and w, and that those two pieces are congruent, and so they must be equal. You can set them equal to each other, and then use a little handy-dandy algebra to get a value for x. Once you get your value for x, jam it back into one of those expressions and find the distance of each piece, and then add them up to get the total amount. It looks complicated, but with a little practice, you're going to do just fine. So these problems, this one here that we just did, and these right here, we're being told what the midpoint is, and that's great. And so when you're told what the midpoint is, you can do a little bit of calculating depending on what you have. Sometimes it's a little bit complicated, but you can use the midpoint to find out lengths of segments. But sometimes you have to calculate the midpoint of a segment. This is like the warm-up. There's a handy formula for that. Now remember that formulas are like recipes. They just take the pieces that you need, toss them all together, and then spit out what you need. So here's the midpoint formula. It looks like this. x1 plus x2 over 2, and then y1 plus y2 over 2, all wrapped up in parentheses because it's a point. Notice it is a midpoint. And that's going to give you some x and y when you're done calculating. This formula says that if you know the endpoints, you can always calculate the midpoint. Now might be a good time to pause this video and get this formula into your notes because you're going to use it. All right, here we go. So here's what a typical midpoint calculation problem will look like. You're going to be told what the endpoints are, and this says the endpoints of RS are R at -5, -3, and S at 2, 9, and we need to find the coordinates of the midpoint. So we know the endpoints, and we need the midpoint. So we have to calculate it. So notice this formula has a lot of letters in it, and it's got all this like little numbers and stuff, but let's break this down. It's not as hard as it looks. Remember that points have x and y values. We could very easily call this x, x1, because it's the first x in the problem. We could call this one x2, because it's the second x in the problem. We could go back and label our y's. Now, if this is x1, that one has to be y1, and this 9 has to be y2. And if you do that, now you can just take those values and plug them right into the formula, just like you would with a recipe. You're getting told that you need a certain amount of ingredients, and you're going to plug those ingredients in. So the formula says start with x1. Well, what is the value of x1? It's -5. And then the formula says to add. so we will. And then we want to find the value of x2. Well, let's see. It looks like that is 2. Now, the formula says to put that all over 2, and so I'm going to. The formula also says that you need some parentheses, so I'll put that in. And the formula says to put a comma between them, because remember, what you're calculating is a point. And so you're going to need a comma between the x values and the y values. Now you're going to find the value of y1. Do you see it in the problem above? y1 is -3. The formula says add, so we will. And then we need the value of y2, which is 9. And then all of that over 2. Over 2. And then close off your parentheses. Now, this part right here is just telling us what we'll get at the end. And so we can now just calculate using what we have. Because now that we have all numbers, we can just combine those numbers. So we can simplify on the left side by saying, what is -5 plus 2? Well, that's -3. And that's still over 2 because we haven't done anything with that 2 yet. And comma, what is -3 plus 9? Well, that's 6, and that's still over 2. Okay, that's the first simplification step. Just combine those numbers on the top in the numerator of those strange-looking fractions. And now on the left side, the x values, we have -3 over 2. Now you could say that that's -1.5 if you want, but you could also just leave it as -3/2 because that's, simply beautiful. But you can also simplify on the right side, the y values, 6 over 2 is 3. And so we know that the midpoint of our segment is at -3/2, 3. And that's how you do this. You identify your x and y values, you plug them into the right place in the formula, and then you simplify. Okay, let's do another one. So we have the endpoints of A, B are A and B, and they are at 1, 2, and 7, 8. Find the coordinates of the midpoint, and we can just identify our x's and y's, plug them into the formula, and simplify. So this one is the first x, and here's the first y. So there's your x1 and your y1, and here's your x2 and your y2, and that was really the hardest part. Now we just take those values and plug them into the right place in the formula. The formula starts with some parentheses, and then it asks us for the value of x1. Well, x1 in this case is 1, plus, what is x2? 7. Now it's going to be really tempting to put a 2 here. Can you see why you might? Because you might think that you just put these two numbers together, but you don't. Notice the formula has x's together and then y's together, which is why it's kind of important to label these things. Okay. I'm going to go back a little. Oh, I can't reach it. Oof. Try to get rid of some of this. There we go. So we have 1 plus 7. Those are the x1 and the x2 over 2, comma, and now our y1 is 2, plus our y2, which is 8, over 2, and close your parentheses. Now we just need to simplify on the top, and I would encourage you to keep those parentheses because at the end you want a point, and points are going to have parentheses around them. So 1 plus 7 is 8, over 2, and 2 plus 8 is 10, over 2. Can you keep simplifying? You sure can, because 8 over 2 is 4, and 10 over 2 is 5. And now we know that the midpoint of segment AB is 4, 5. No longer do you need to eyeball these and make a good guess. You can calculate the exact midpoint of that segment. All right, let's do another one. The endpoints of CD are C at -4, 3 and D at -6, 5. Find the coordinates of the midpoint. When you're asked to find the coordinates of the midpoint, you're going to use the midpoint formula. That's what it does. It calculates midpoints. So identifying our pieces, here's x1 and y1. Sorry about that feedback. x2 and y2, and now we can pull those values right into the formula. x1 is, let's see, let's start with our parentheses. x1 is -4. To that we're going to add x2, which is -6 over 2, comma, and now our y values, y1 is 3, plus y2, which is 5, over 2, end parentheses. All right, simplifying on top, we have -4 plus -6, which is the same as -4 minus 6. So if you start at -4, and then you go more negative 6 places, you're going to get -10 over 2, comma. 3 plus 5 is 8 over 2. And now simplify those fractions. What is -10 divided by 2? It's -5. And 8 divided by 2 is 4. And now we know the midpoint of that segment is -5, 4. Plug those endpoints in, calculate, find the midpoint. That's what the midpoint formula does. And that's it. It's really all there is to it. Your practice is going to be on Big Ideas Math. It's called the midpoint formula. Don't forget to look for that in the fine print. Your essential question, how can you find the midpoint of a line segment in a coordinate plane, should be answerable. The answer is use the midpoint formula, right? If you're having trouble with these, go back through the video and review some stuff. Remember, we have office hours, and I'd be happy to show you how to do this in person, or at least over a Google Meets. I hope that this made sense, and I hope you have a wonderful day. I'll see you the next time I see you. Bye.